up your voice. Okay, so first question, an incomplete equation is given, sulfuric acid, salt. Any problems with identifying X over here? If you have an acid plus a metal, it's a skeleton reaction. Any problems identifying the product there?
No.
No, so it should just be hydrogen.
No.
Cool. So that's pretty straightforward, nothing too difficult with that. So you just remember acid plus metal gives you salt plus hydrogen. Ooh, which property do all metals have? They are hard, less dense in water, they are very reactive, and they conduct electricity. So are all metals very reactive?
No.
No, so
No.
things like copper, gold, and silver, not all metals are very reactive, but most of them are quite hard. They are less dense than water. Oh, sorry, which property do they all have? Sorry, I misread the question. Sorry, which property do they all have? They all have electrical conductivity.
Yes.
Sorry, yeah,
Yes.
I'm an idiot. So some metals like sodium are very, very, very soft. You can literally cut sodium with a knife. Sodium, potassium, calcium, those sorts of things, they're extremely soft. Not all are less dense than water. Sodium is less dense than water, but metals like iron, copper, steel, whatever, they'd obviously be more dense than water. And then not all metals are very reactive. But one property of metals is that they all conduct electricity. Cool. Bauxite and hematite are important ores. Which metals do they contain? Bauxite is aluminium and hematite is iron. I know it's probably not mentioned in the syllabus, but it does say it in the extraction part. When they talk about extraction of iron, we talk about hematite, and when we talk about extraction of aluminium, we talk about bauxite. Cool. Any problems there?
No.
No? Good. Good. Happy days. What is made from aluminium because of its low density? Aircraft frames. So all those other things are correct, but it's not because of the low density. So food cans would be probably because of the low reactivity, pencil sharpeners probably because it's cheap and malleable, and window frames probably because it's unreactive. But the low density here is referring to the fact that it's going to be extremely light. Also the fact that it's going to be extremely light. But all those other things are made of aluminium, but for different reasons. Cool. A container is to be used to store either dilute sulfuric acid. So we want something that is not going to react with the acid. So we want something like glass and polyethylene. Glass obviously is very unreactive, and polyethylene you'll see later with organic chemistry. Polyethylene is just plastic. Ooh, and plastics are very unreactive. Ooh, any problems with that one?
No.
Yeah, so you wouldn't obviously make it of magnesium because magnesium is extremely reactive. That would not be good. So anything that contains magnesium is not obviously a good answer. Oh, uranium is a radioactive element, typical metal, not a property of uranium. It forms a covalent chloride. And the reason it doesn't form a covalent chloride is because it's a metal and it'll form an ionic chloride. Cool, so it's a metal plus a non-metal, but all those other things are correct because they're properties of metals. Cool, any problems with that?
No.
No, good, happy days. So it will form an ionic chloride because it'll be a metal plus a non-metal, so it'll be an ionic chloride. Mild steel is used to make mild steel is stronger than iron. Well, mild steel does rust. Unfortunately, mild steel does rust. So if you ever noticed an old car, especially if the paint chips, you definitely start seeing a little bit of rust. So mild steel does rust, but it's a bit stronger than regular iron. So regular iron is extremely soft. You can probably bend it with your hands. It's like copper wire. You could probably shape it as much as you wanted to. Ooh, any problems there?
No.
Good, happy days. Which of the oxides, copper, magnesium, and sodium can be reduced heating with carbon? So you've got to remember your reactivity series, and anything that is below carbon on the reactivity series can be reduced with carbon. So in this case, it would be copper oxide and nothing else. So copper oxide only. So if you look at your reactivity series, carbon would be here, Copper would be below it, magnesium would be above it, and sodium would be above it. So anything below carbon can be extracted with carbon. Oh, any problems there?
No.
Nope, everyone happy?
No.
Good, good, good. So extraction with carbon only for metals that are less reactive than carbon, so below carbon in the reactivity series. The diagram shows two elements that contain zinc, and they're saying which is zinc an alloy. In the case with the galvanized bucket, it's not an alloy. So it's not an alloy for the bucket, but it is an alloy for the knocker. And the reason it's not an alloy here is because it's not mixed. So it's not mixed. So when you look at the sort of bonding structure, the zinc and the, zinc and copper are not mixed into each other. They're not an alloy. The zinc is literally just on top of the iron. Oh, everyone happy with that?
Mm-hmm.
Yeah. So it's an alloy for the brass knocker, because brass is a mixture of copper and zinc. But in the case of galvanizing, we're literally just taking the zinc and we're putting it on top of the iron. So it's not mixing them together. It's not alloying them. Ooh, metal X is below hydrogen in the reactivity series. Which table is correct? Reaction of hydrochloric acid. No reaction. So you only react with acids if you're above hydrogen in the reactivity series. Cool. And then reaction of heated oxide with carbon. So if you're below hydrogen, you're also below carbon. So in this case, you would get the metal formed. Cool. Happy with that?
Mm-hmm.
Cool. So if you look at the reactivity series, you'll find that hydrogen and carbon, hydrogen is somewhere here, carbon is somewhere here, and then there's a couple of things above it, a couple of things below it, and then a couple of things below it. So if you're below hydrogen, you probably are below carbon as well, or something like that. Cool. That's a little bit of a confusing one. So if that one does give you problems, please let me know. Just shout out quickly. I think you're fine. Good, 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 good. Okay. What is the main reason why stainless steel is used for cutlery? So there's other reasons why it's used, but the main reason is it's resistant to corrosion. So it's not necessarily low density because steel is quite heavy. We're not interested in melting point and we're not interested in electrical conductivity. The main thing we're interested in is corrosion. Cool. The equation describes the formation of thing, which substance is reduced. This technically we haven't done because we haven't talked about oxidation and reduction. So I'll forgive you if you didn't have this one, but it's the iron oxide that is reduced. Cool. And reduction literally just means removal of oxygen. Cool. So, sorry, here we go. The word reduce means oxygen removed. Cool. So which chemical has had oxygen removed? And it's the iron 3 oxide. Cool. Any questions with that? We do talk about it as a reduction because when we talk about it as a reduction, we're saying we're removing the oxygen. So we talk about reducing iron oxide with carbon monoxide to produce the pure iron, like we did in the blast furnace. Cool. Any questions there? No?
No.
Good, good, good. Which
No.
substance is malleable element that conducts electricity? So we're looking for malleable and conduction. In other words, we're looking for a metal. So bromine, let's highlight them here. Bromine and sulfur are non-metals. And then what's the problem with steel in this question? What's the problem with steel?
It's an alloy.
It's not, yeah.
Correct, it's an alloy. So it is a metal, but it's an alloy. So when the question asks for an element specifically, the only element in this picture that's a metal is aluminium. Cool. And then bromine and sulfur are non-metals. And then you remember that from that funny little zigzag line on the periodic table on the right-hand side. Cool. A new container is being developed to carry food and water to take on long walks. It needs to be light and corrosion resistant. So we definitely don't want iron, and we definitely don't want mild steel. Now, the question of whether you use stainless steel or aluminium is an interesting one, because I would say that the question is mildly ambiguous, because in my personal opinion, either one of these two would be acceptable. Oh, excuse me,
So-
sorry, the screen, yeah, sorry, stop sharing, give me a second.
Oh.
Sorry, it's the iPad is connected to the Wi-Fi, and if the Wi-Fi conks, the iPad conks. We'll just give it a few seconds. No, okay, so I've got to stop the share and then reshare. Here we go, and try again. Let's see if it works. There we go. So while we're talking about it, a lot of drinks containers, I don't have my camera on, but a lot of drinks containers are actually made out of stainless steel. And the way you can find out whether it's stainless steel or aluminium is by taking a magnet. So if a magnet sticks to it, it's probably stainless steel because a magnet won't be attracted to aluminium. So to be quite honest, both of these are actually used for drinks containers. And stainless steel, if you make it thin enough, is actually quite light. But does anyone remember what the mark scheme says?
I think it was aluminium.
I think it was aluminium, correct. So I think the mark scheme says aluminium. I'll check for you and I'll make sure. But to be quite honest, I would say that this question is mildly ambiguous. So I think this is not a nice question, in my personal opinion, because in reality, drinks containers are made from both aluminium and stainless steel. In fact, I would say most of them are made of stainless steel. If you go to the shop, like if you go to Clicks or something, and if you buy a thermos container, it's probably made of stainless steel.
Aluminium actually might be too malleable. Like it might dent
be, yeah.
or
It
crack
might dent,
too easily.
correct. Yeah, I agree with you. So an aluminium container would be like a Coke can, and Coke cans, you know that once the Coke is finished, you can literally crush it with your hands. But you can obviously make the aluminium a little bit thicker. So it really depends on cost and availability. But quite honestly, this is a stupid question in my opinion. So because you understand that both of them are not corrosive. You understand that aluminium is light, but in reality, stainless steel can also be quite light because you can make it a lot thinner. So you could probably think of it this way. You could probably have a thin stainless steel versus a thick aluminium. And if you put that on the mass scale, they would probably have exactly the same mass. So it's a stupid question, in my opinion. And this is going on YouTube, so everyone in the world can see that.
Oh no.
Cool. So metal M is to be extracted. It's extracted. M is extracted from these compounds by heating them with carbon. So if it's going to be extracted with carbon, it definitely has to be below magnesium. This carbon is probably somewhere in the middle here. I think carbon fits just over there, if I'm not mistaken. Cool. And then what's wrong with D? Why does D look a bit odd? What do you find odd about D? If it's less reactive than copper. Ooh, anybody? What do you think about D? Do you think we need to extract D, or do you think we're going to find D just like as an element in the ground that we can pick up?
An element that you can pick up.
Yeah, they call these native metals, and the word native just means that they found as metals, meaning we don't have to extract them. So gold, silver, platinum, all these things, they found like contained inside rocks, but really all they have to do is crush the rock and then pick out the little pieces of metal. They don't actually have to extract it. Cool. So the only one that's below carbon that probably needs to be extracted is C. Also, that's a little bit of a sneaky question because you have to kind of think where carbon fits in, and it's definitely below magnesium, and it's probably above zinc. But even if it's below zinc, it doesn't matter because C is still below zinc. So by process of elimination, the answer can only be C or D. Ooh, and then we get rid of D because D is probably so unreactive that it doesn't need to be extracted. Cool. A, B, C, and D are the properties of four metals produced from iron ore. Which properties are most suitable for making cutlery, resists corrosion, and is hard? So you just want corrosion resistance and hard. You definitely wouldn't want something that rusts, so that's silly. And you definitely don't want something that's going to be soft, because you don't want to eat with a fork that's going to bend every time you press down on the plate. Oh, and you definitely don't want something that's brittle, because brittle just means it's going to snap if you apply pressure. Cool. 4 different metals are placed in dilute hydrochloric acid. Which metal would not react? And it's copper. Also, copper is the only one that's below hydrogen on the reactivity series. All the rest of them will all react with acids. Unfortunately, you guys weren't in class, but this is literally an experiment that we do in class. So I literally take all these 4 metals, almost exactly these ones, and we do put them into little test tubes, and we do test the reactivity of all of them. And then what you notice is that the copper, even after 2 or 3 days, has done nothing. The iron is very slow, very, 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 very slow. So you don't really notice it immediately, but after about 2 or 3 days, you see that the iron's almost disappeared. But the magnesium and zinc are almost instant. Metal M is formed when its oxide is heated with carbon. Which deductions from this thing? So yes, it's similar in reactivity to iron, because iron is also extracted using carbon. It's definitely not more reactive than potassium, because if it's more reactive than potassium, then it's high on the reactivity series. So you'll find that potassium, sodium, calcium, and then eventually you'll get to carbon. So it's carbon, and then you'll have zinc, iron, etc. Cool. And then the oxide of M is not acidic, because it's a metal oxide, and you have to remember that metal oxides are basic. Cool. So metal oxides are basic. So you probably can't read that. But that leaves you only with option number 2. So the answer has to be 2 only. Cool. Anyone, any questions about that?
No.
No, sir.
You good, good, good. Cool. Copper, iron, zinc are all used to make things. Which of these 3 are also used to form alloys? We alloy, copper, iron, and zinc are used to make things. Which of these 3 metals are also used to form alloys? All of them. Cool. So we combine iron with, we can combine iron and zinc to make, we can combine iron with carbon to make steel. We can combine copper with zinc to make brass. We can combine zinc with other metals to make other alloys. So all 3 of those are used in the form of alloys. Well, not necessarily with each other. So we don't necessarily mix all of those. So like we don't often alloy copper with iron, for example, but we do alloy copper with zinc, and we do alloy iron with zinc, for example. Cool. Any questions there? You good?
Mm-hmm.
No, you're good, 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 good. So table shows some reactions of 4 metals and their oxides. So you've got to really think carefully about the reactivity series, and you've got to think, this is probably one of the trickiest questions. So you really have to look at the reactivity series when you do this one. Cool. So let's have a look quickly. If we find reactivity series. There we go. So take something like that. Is carbon on there? No, carbon is not on there. Let's find one that has carbon. There we go. There's carbon on that one. Okay, cool. So there's the reactivity series. And what we need to do is just use the reactivity series to see, can we, let's find that there. There we go. So hydrogen is below carbon. So anything that reacts with carbon will also react with hydrogen. But the lower you are, the more easily you will react, with carbon, and the more easily you will react with hydrogen. So anything that is here on this side over here will react with carbon and hydrogen. And then anything that's below hydrogen will be the most or the least reactive in terms of reaction with hydrogen. So let's have a look. So metal with dilutes acid, and we have fast reaction versus reacts. So would you agree with me that Z is probably the most reactive? Yep.
Yes.
Yeah, so Z must definitely be the most reactive because it's the only one that reacts with hydrochloric acid, and it's an extremely fast reaction. Also, by that thinking, we can get Z and that. Then the question is which one is more reactive, Y or W? And to see which one is more reactive, we have to say, is it not readily reduced or is it reduced? And for this, we need to look back at the reactivity series. So the one that is easily reduced is the one that's going to be below carbon, and the one that's not readily reduced is the one that's going to be above carbon. Cool. So we go back and we have a look, and then you'll see if it's not readily reduced, it means it's more reactive. Ooh, and then this one is less reactive. Also, in that case, we can say then the next one in line is W. Ooh, and then we basically finished the question because now the only option we have is ZW, and that's in A. Also, I would say that's quite a tricky question. Any problems with that one?
No.
Yeah, so you just need to look at the reactivity series and make sure you understand everything relative to carbon and relative to hydrogen. So look for carbon and look for hydrogen in the reactivity series. There's carbon and there's hydrogen. Don't save changes and go back. Cool. Why are some iron objects galvanized? To increase density, to lubricate, to produce an alloy, to stop corrosion. Cool. So we add zinc on top of iron because we know zinc is more reactive and it's going to sacrifice itself. Also, we call it sacrificial protection. Yeah, so the zinc literally gives up its life for the iron. It sacrifices itself. Cool. Copper as metal has the following properties. Sodium group 1, which metallic properties are shown by sodium? So although sodium is a metal, it doesn't necessarily show all of the metallic properties. It doesn't have a high density. It's not hard, but it will conduct heat and it is malleable. So 1 and 4. Also, group 1 metals we'll talk about later when we do this chapter called periodic table. And when we do the chapter periodic table, we talk more about sodium, potassium, cesium, and all the group 1 metals. And you'll see that most of them are quite soft and less dense than water. So it is a topic that we will do afterwards. Cool. Which metals are found as ore or native? Which row identifies a source of aluminium, copper, gold, and iron? So copper, it's not in the syllabus anymore, but it's you find it in what's called an ore called malachite. Some of you might have seen this before. It's that greenish, blackish mineral you can make jewelry out of. You can buy it usually at the side of the road from the curio people. Malachite, you'll see now, it's this beautiful green stone like this. So that's malachite, and that's a copper-containing ore or a copper-containing mineral. So that's the ore of copper. Aluminium is bauxite, iron is hematite, and gold we find native. So the answer is A. Cool. Any questions there? No?
Nope.
Good. So brass is an alloy. Which element is added to copper to make brass? Zinc. Also, you just have to remember that that's in the syllabus, and they say that under the uses of metals, they say that explain the use of zinc in the alloying of copper to make brass. So it's one of the few types of alloys that you have to be aware of the composition. So brass is a mixture or an alloy of copper and zinc. Cool. Which metal produces a solution of metal hydroxide when added to water? So in the reactivity series, not all the metals react with water. We know that the ones quite low down don't react with water. So copper is way, way too unreactive. So definitely not copper. definitely not iron, and definitely not zinc. So if you look at your reactivity series, calcium is whoopsie, excuse me. Calcium is the only one that's high enough. So there's calcium over there. And it's going to react with water to form the hydroxide. So the answer there is calcium. Cool. So you guys happy with the multiple choice? I didn't hear any questions, so I'm guessing most of you are happy with most of those questions.
Yeah, yes.
Yeah,
Yes,
good,
sir.
good. Cool. So the nice thing with these questions is if you have gone through the work and if you have read through the syllabus and if you have read through the notes, the questions basically show you what kind of questions you can expect. So it's a good indication of what the next type of question will look like. And you can imagine that the next type of question is going to look exactly the same, if not similar, if not exactly the same. Also, it's a very good idea just to, if you're going to study for a test or an exam, to actually go through the questions again. And if you have any questions about them, maybe later, you can obviously ask me again just to explain one or two of the answers. Cool.
Yep.
Happy days. Okay, so guys, take a, let's call it, let's say 15 minutes, and then just come back for 10 minutes quickly. Then we can talk about the next lesson, the next few topics. So just come back quickly for 10 minutes in 15 minutes time. So come back
Okay.
at 10 to 11.
Okay.
So come back 10 to 11, then we can just